Okay, let's talk about scientific notation. In scientific notation, I usually have a number, which is n is represented. This is a number in which only one digit is placed to the left of the decimal, times 10 to the n, where n, smaller n, is the exponent of 10 by which the number is multiplied. If I tell you that the temperature of the sun is 15 million Kelvin, this can be written in scientific notation, and I would write it as 1.5 times 10 to the 7 K. Again, I'll need one number, one digit, is placed to the left of the decimal point. The 7 represents the exponent of 10 by which the number is going to be multiplied. And if you multiply this out, it will give you 15 million. Okay. So let's look at the number 1234.56. I want to write this in scientific notation, meaning I want one number in front of the decimal point multiplied by 10 to the n. So let's figure out what n is going to be. So if I can write this number as 1234.56 times 10 to the 0. 0 representing that the decimal point has not been moved. But if I move it over 1, so that it's now between the 3 and the 4, it's going to be equal to 123.456 times 10 to the 1. I've increased the exponential by 1 because I moved the decimal place over one space. Now if I take that number, 123.456 times 10 to the 1, and I move the decimal place over another space, so that's now between the 2 and the 3, what it is now going to be equal to is 12.3456 times 10 to the 2. Again, the exponent has now increased again by 1. If I move it over one more space so that it is between the 1 and the 2, what I get is going to be equal to 1.23456 times 10 to the 3rd. Again, I have increased the exponent each time I've moved the decimal place over. So writing the number 1234.56 in scientific notation, the result will be 1.23456 times 10 to the 3rd. Again, I have one number in front, one digit, one non-zero digit in front of the in front of the decimal place. And my exponent is 3 because I moved the decimal place over 3 spaces from where it was originally. So each time the decimal place is moved one place to the left, when I move it one place to the left, the exponent is increased by 1. This is considered a positive exponent. When I move it to the left, I get positive exponents. Now, when do I get negative exponents? If I have the number 0.00657, you want to write this in scientific notation so that I have one non-zero digit in front of the decimal point. Again, starting off with the original number times 10 to the 0 because the decimal point has not been moved. If I then move it one place over to the right, I get 0.0657 times 10 to the minus 1. Taking this number, if I want to move it one more place over, so that's between the 0 and the 6, I will get 0.657 times 10 to the minus 2. I'm increasing the exponent again each time I move it, but I'm increasing it in a negative direction. So now I take this number and I move the decimal place over one more time so that I get 6.57 times 10 to the minus 3. I now have one non-zero digit in front of the decimal point, so this number is written correctly in scientific notation. My answer is 6.57 times 10 to the minus 3. Each time the decimal place is moved one place to the right, I'm moving it to the right now, the exponent is decreased by 1. I go from minus 1, minus 2 to minus 3. The exponent is decreased by 1. This is considered a negative exponent. And this completes our lesson on scientific notation.